So this week we are going to talk about UML, class diagrams. I'll do a very quick overview of what it is and how our system would look like uh, as a UML diagram. Usually, it's like we're working backwards in this case. We already built most of the system, but usually after you do the SRS is when you start working on the UML class diagrams. So I know it's coming a little late, but I think it's just important to kind of cover that so that in the future, that's the approach that we're going to take. But before we work on the UML class diagrams, I want us to quickly go through the assignment. Now, this is a very, excuse me. Um, I know this is a very old assignment. So let me share my screen. And we've been working on Tailwind for a while. I don't know if you guys were able to make the changes I was able to give you. Like the from the comments I made. I don't know if you guys saw the comments. Okay. I know for you, Edwin, you were able to. I was able to merge your work because it was pretty good. Yeah. So your work technically is done. So whatever assignments I come up with this week, which I'm actually thinking of just giving you something to write about, more like critical thinking or something of the sort, instead of just coding. Because yes, there'll still be some coding required, but I'm thinking of switching it up a little bit and having you guys write like a one pager on a certain topic, just to make sure you guys understand what it is and why you have it in there, why we're using it. Yeah.
Okay.
So I wanted us to review a few things. So Edwin, you good? What about Abby? Did you manage to work on the comments I left out? Let me just check what comments I left.
Yeah, but
Mhm.
I'm not sure if those were all the comments. So I just did what I could see on there.
Okay. So meaning oh, you were able to resolve merge conflicts. That's great. Um so that's why so I'm gonna today after this call I will check your work again just so that I can actually review the work. So my initial
Okay.
challenge was that the merge conflict thing, and I didn't want to resolve it because I wanted you to resolve it so that you can learn how to resolve it. So
Mm,
I wanted to, because I found that you were not the only one with the same issue. So I wanted to kind of highlight this part on always pulling from main. So every time you work on the code, like every day, you worked on it today, you're still working on the same thing tomorrow. The first thing you do before making any changes that day is just pulling from main, so that um, if there are any changes that are done, you can you can get them, and then do what you need to do to make sure they align to what is in main. because whatever is in main is not going to change. So it's now for you to take the changes and see how to make sure that you work within the already set changes. I don't know if that makes sense to everyone, if everyone is okay with that, or um, yeah.
Yeah, yeah. I am.
Okay, okay. It's usually just best practice, and it's mainly because if you stay too long before pulling from main, and then you pull from main, you'll have so many merge conflicts to um, let me add merge. You'll have so many merge conflicts to resolve. So, hi Morad, I hope you're good. I was just we were just reviewing last week's work and the comments that I made, and I was starting with Abby, and I was telling her that everyone, that best practice when coding is every day we pull from main so that we resolve any merge conflicts that might be there. So another thing I noticed was, I know this is not for everyone, I'd say Faith, when working on your PR, I couldn't find, your template was empty. I don't know if there was nothing on the template. So I wanted to know if you've ever used the template before, or maybe we could go through the template filling process so that you can be familiar, or it was something that you forgot. I'm not sure.
I forgot to fill it. I think maybe you can help me out with that.
Okay, cool. That's great. So
Okay.
what happens? Let me take let me create a new PR, because that's when it let me take that. Oh shoot. Let me take, yeah. Okay. It's already there. Let's see if I can create another one with another branch that hasn't been. This one is already there. Can't seem to find. This one is already there. Okay, this one doesn't have it. So when creating a pull request, so you click the create pull request, this is the page that you'll find. I don't know if you guys can see this, or I should zoom in a little bit more. So you've seen that step, right? You've seen I went to pull requests and then I chose a branch and then created pull request. So it'll come to this page. So if you preview, this is how it looks like, but this is where you can make the changes. So you will come and remove this comment and then put the title, and then you come and change, you'll add the description, and then if there's an issue, you guys remember when we went through issues, right? Previous class when we were going through Agile. So let's assume if we had an issue there, we would be like issue number 5 maybe, and then it would be added there if it's there, that is. And then for this will cover the things that have been changed. So in our case, maybe because we were just migrating from traditional CSS to Tailwind, we'll say it's a refactoring. So you put X in the box, and maybe you also fixed something bug that you found out, when you were doing the migration. And then maybe you would updated the documentation. So this one too. So the comment here is to delete options that are not relevant. So you can do that so that the focus is just on this, the ones that are there, or you could leave them. Honestly, this is optional. So yeah.
Mm.
So if you preview your work at this point, this is how it looks like. So this one's I checked, and then anyway, let's finish. So this is about making sure that you tested your work before creating a pull request. There's some people that are notorious of just making changes and then creating a PR and asking people to review before they test. So this is to validate that, okay, I manually tested this feature and it's working. Or if we had automated tests, each ran and everything is good. If it didn't, if there was an issue, you can also add it in this additional notes. And then this is additional stuff you can check if it covers any of this. You can also say, I have reviewed my own code, and you've updated maybe documentation. If you have any pictures, because sometimes you might have like a before and after. Maybe it's something that's visibly, when you've changed it, you can visibly see it. So you can take a picture and attach it. You can just pick it and drop it here. And then additional notes would be when you're running this thing, make sure that your setup is looking this way, blah, blah, blah. Anything that would help the person who's running your branch when they're testing to have an easy time. And then once you're done, you'll just create the pull request. So I guess I can create it and just see. So you see the whole. So automatically, I will be added as a reviewer, and that's why at the end you will find. Okay, after this has been resolved, you'll find that I still need to review it before it's merged. But this is how it'll look like. And if there's something you've missed, that's why I left out the these options, you can still just click on it and it'll get checked. So when I am coming to see your work to review, I will first go through here, be like, oh, okay. So this is what they did. Okay, this is how they tested. Okay, this is what it covers. If there's a screenshot, I'll look at it. I'll have a quick. It'll be so easy for me to have an idea of what changes you made, and what what I should expect to see. So that the first thing when I go here, I can just click um, on the files that have been changed. But this is 3000, and I'd say it's 3000 because the .env file, no, dot the gitignore file is an old one, so it's also updating or monitoring files that are system generated files. That's why it's 5000. So if once the merge conflicts are resolved and including changes to the gitignore file is like done, some of them, most of them. See the bin, like this bin, yeah, that's what's making it this number, which is insane. Any questions, especially Faith, because I know this is something we were specifically going through for you.
No questions. I have gotten the procedure.
Okay, that's
What
great.
I'm gonna do is, yeah.
Okay, so even in your branch right now, when we go through it, you can actually still do some of it in regards to like checking. You can click on the checkboxes that apply. Yeah, not sure if you can change the, yeah, you can change it. So you can come in and just make the changes, like update it with what you, um, the changes that you made. Yeah. Any questions? Okay, great. Hi, Noella. Welcome to the meetup. Um,
Hello everyone. Hi.
hi. Hi. So we're reviewing last week's assignments and some of the things that I wanted us to talk about included. So we've talked about always pulling from main, and when you pull from main and the changes, there's a chance there'll be a merge conflict. So resolving merge conflicts, and then we've just talked about filling the PR template. And then the other thing I want to talk about is branching. So naming convention for branches, and I mainly wanted to talk about this because of Morad. I noticed your branch name was just Morad, your name, but the convention is. Let me take us through that really like for 2 minutes. So we have, if you look at the README file, I think there's a part that talks about creating, yeah. So this is how we recommend having the branches. So your name and then what you're doing. In this case, it could be a feature, bug fix, refactoring, whatever it is, and then most people have been doing their names and then tailwind migration or page tailwind migration, something like that. But so you start with your name and then whatever your branch is working on. So that will help me understand what that branch, like what that, when I'm going through the PR, what that branch is expected to do. Just even if it's not detailed, just gives me an idea. There's a chance we'll have so many branches in the future, so um, naming your branches accordingly kind of makes the process easier. It's just similar to when you're naming variables. So when you give variables meaningful names, it's easy for other people to read your code. Yeah. So I'd say Murad, the next exercise, maybe we can work on that. And if you need any help in figuring out how to name it, you can just put it in the chat and then we can help you out on that, or just reach out and then I can help you out with that. I hope that makes sense. And if you have any questions, please, any questions on that?
Okay, thank you. No questions.
You're good. Okay. So this is just feedback. So FYI, let me put it out there. This is just feedback. I am not saying anyone is doing anything wrong, because we're here to learn, and it's all about identifying best practices and sort of shifting from what we are doing to best practices. So you can never have like I'm trying to put trying to think of the best word. Anyway, it's not a mistake that anyone has made. It's more like feedback for better work in future. So Faith, Murad, yeah, that's consider that as like feedback, not how do I put it? Like not a bad thing. Yeah, yeah. Don't take it.
Okay.
Yeah. So now we can get into the today's presentation. So we are going to cover UML class diagrams, and this is sort of like looking at our system through models that we have for different through models for different entities. Is anyone familiar with UML class diagrams or heard of UML? Okay, okay. So I know this is more theoretical. So if you were going through a computer science class, there's a chance that you will go through this. Very high chance. So we will cover a brief introduction. We'll talk about the core elements, and then we will look at diagram notation for UML diagrams, and then see how we can map what is in this SRS to UML class diagrams. And then we look at one example of a UML class diagram, and look at association and UML classes, look at what multiplicity is, and then see the whole system as the UML class version of UML class diagram of the system as a whole, and not just one of the classes. I know we've gone through this already. So UML is in full unified model language, and it's a standard for modeling software systems. It's able to show us the classes, its attributes. Attributes in this case are like the properties of the classes, like the variables that it has, and also methods that it has, and then the relationships. Because we know, for instance, we have task class and a subtask class. So knowing how they relate to each other is very important. So I don't know if I mentioned this before, but ideally, this you creating UML class diagrams is supposed to come after creating an SRS. So we're kind of working backwards in this case. So let's just assume we haven't developed anything, just to be on the safe side, like just to easily visualize like how this would be important for us when we're just getting started with the project. So UML class diagrams helps us do that. So it helps us identify the classes, identify the attributes and in the for the classes we'll have, that is methods and properties, and then the relationships that these classes will have to each other. So it has things, which are classes, attributes, which is data, and then operations, which is behavior. It shows us how they relate, like associations, aggregations, composition, and inheritance. And then it captures something called multiplicities. So, like there's some that have one-to-one relationships, or one-to-many, or many-to-many relationships. And then roles is more like this one is apparent to the for the subtask would be a child, so apparent to a child task. And then constraints is just like if it's unique, required. For instance, when we are filling out a form, we could have required fields or unique fields. So core elements. Guess I'm repeating myself in some of these things, but repetition is good because that's how we learn. So the core element is one of them is you'll have the class itself. So this would be a table with a name and then attributes like the properties, variables and all that. And then you'll have operations, which are the methods in the classes. Another thing that's usually there is you will find the, I can't remember what is it called, like if it's private or public or protected. I think we'll see it a little bit after this slide. And then we also have associations, multiplicity. So 1 to 1, 0 to 1, 0 to many, 1 to many type of relationship. And then composition, this is more of visually, it's like a filled diamond and it shows that it's a strong relationship. We will not go into detail with that one, as well as aggregation. We won't go into detail with that, but visually, it will be represented as a hollow diamond. This means that that connection isn't too strong, so it's not too. It's anyway. It's not a relation. It's not a strong bond. And then generalization is more on inheritance. It's more about inheritance. Excuse me. We will also not go into details with that, but these are the core parts of UML classes. What we'll cover today is more on associations. The main reason why we wouldn't go through the last three is because they need a lot of we need to do more reading on that and more exercises on that, and considering this is like an intro, not to say class, but an intro topic, I'll just keep it on the surface level, and then hopefully in future we will start diving deep into each of these each of the other sections. So diagram notation, that means what each of this, what we see, what it means. So we have the attribute format, which is attributes in this case are like let me go to an example. You see this parts, these are the attributes. I know it's easy to talk about them when you can visually see it, but like title, description, due at, status, all of this, these are considered to be attributes, and then these ones are considered to be um, methods. And then this is the name of the class. So this as a whole is a class. So we'll have a similar thing for subtasks, for category, for user profile, each of them with their own properties and methods. So let me go back. So we can include constraints. So in our case, I know I haven't included constraints, but we can include it and be like ID is unique or required. So ID can be unique, and then we can say email is required. So something like that. That's how you add the constraints to the UML class. And then derived or computed property name. Let's see. Can't remember what this is about. Let me talk about the next one, which is visibility. So if it's a public, if it's something that's publicly accessible, it'll have the plus sign. If it's a private property or method, it'll have the minus sign, and if it has this hashtag, it's protected. What do you guys know about public, private, and protected? If you guys remember. Public, private, and protected. Anyone?
So, like, for example, in classes, we have
Yes.
private and public.
So we both in the classes in terms of properties and also in terms of methods. So how do you understand by when I say that, let's say a method is public or a, let me go to that diagram. So like this one, we can see that all of this are public because they're like plus plus plus.
Yeah.
But there's a chance it could have been a minus or a hashtag for protected. So what do we mean when we say that? Anyone?
I think public can be accessed like from outside, and then
Mm-hmm.
private is within the same method, but it can be accessed outside.
Wait,
And then
repeat private.
or private can be accessed can't be accessed outside, but it can only be accessed inside the same um
Mm-hmm.
method. So
Mm-hmm.
for protected, I'm not sure.
Okay, that's a really good one. Anyone want to try out the protected?
I was gonna say it can be accessed inside the class and the subclasses.
Yes, that's for protected, exactly. So anything that inherits from that class can have access to it, which is exactly equivalent to what you said, the you said subclasses. Yeah. A subclass is just a class that has inherited from another one, right? So public, it can be accessed anywhere, like other classes can access it, or anywhere else in the system can have access to that, whether it's a property or whether it's a method of that class. Private just means you can't access it outside of the class at all. So if it's a private field, let's say, let me go back to the visual. Let's say description is private. That means only the methods that are within this class, they'll be the ones that would be able to access it. And in this case, we usually use getters and setters to sort of make changes of any private uh, property. But that's something we will talk about when we are going through OOP. But it's just a way of making sure that some things are safe and like cannot just be easily accessed by anyone. And then protected is, it can be accessed by, like Abby has said, a subclass, meaning any class that inherits from that class can access those fields or methods. Okay. So we also have enum types, enumeration types. In our case, we can have that under status. Anyone familiar with enums?
No.
Okay. So enums are like fixed options, something like that. In this case, in our case, we want to, I'll look for the exact definition, but they're usually in cases where we have options like the status. Status can be not started, in progress, completed, right? In our case. So we want to restrict the system to pick between those three. Because otherwise, if we don't explicitly have those three, there's a chance that someone might decide to have, instead of in progress, like they could be active, they could have it as active, or instead of completed, they could name it done, something like that. So with enums, it kind of restricts the options that you have when you're working with a certain class. So we know that under status, we have three options available: not started, in progress, and completed. Let me look for the exact definition of enums. Um, okay, so enums. Sorry, just give me a second, guys. I am trying to. Yeah, so in Python, but usually this applies in other languages also, it's a way to define a set of named immutable uh, constants, providing code readability and maintainability. So let me see if I can find another. Okay, I look for better documentation for this and then share it with you all. But as I said, it just fixes options that you can have under a certain class. Like when you're picking, for example, a status, you can only pick within the fixed ones, the ones that are available, which are the three that are available. And you can't pick anything outside of that. So it really helps have like a standard of some sort. Like you all will be using the same three options at this in the system when you're working on the system at all times. Um, and then constraints are just giving you like what ability does that, let's say, property have. Is it unique? Is it required? Is it immutable? What do we mean by when we say immutable? Because it has come up also when we were talking about enums. We said uh, it's a way to define a set of named immutable constants. So what is immutable? Or from what we've talked about, what do you think immutable means? Anyone? No wrong answers. We're just having a discussion. Yeah.
Does it mean like unchangeable, like something that can be changed?
That can't be changed, right?
Yeah. Mm-hmm.
Yeah. Yeah, that's what it means. But let me look for um, the definition. Unchanging over time or unable to be changed. Yeah. So when we have some things like constants, we could use constraints like that because we know constants are just constant, they're not going to change. And then when we're talking about enums, we also said we are representing values that are immutable. So under status, you have the three, and you can't change any of the three that have already been defined in the system. Okay. I hope that. Any questions on that? I hope I didn't confuse anyone. Okay, let's
That's
continue.
all good.
Sorry?
I'm saying it's all good.
Okay, okay. So
Mm.
let's see how we can map what we had in the SRS to our classes. You guys still remember the SRS, right? Like the software relational, yes, software requirement specification document. You all remember where it is?
Yeah.
Have you gone through it at all? I know that's something we worked on weeks ago. And I'm actually going to give you guys an assignment on that soon. So yeah, we missed an assignment on use cases. So anyway, like I said before, when ideally these UML class diagrams are supposed to come just after we worked on the SRS. So the SRS has given us an idea of what the functional and non-functional requirements are. It's given us an idea of the use cases and the steps within each use cases and the alternative flows and all that. So now we want to map the system and like visually represent the system in models and as a model. So we had tasks and subtasks, and that one will translate to task and subtask classes in UML class diagrams. So for category, we'll have category class, and this one, the relationship between that and the task would be a many-to-many relationship. Anyone care to explain that? Why we would have a many-to-many relationship with tasks? Like what that means? If you guys could, you know. No, I'm not saying guessing, but more like um, what's the word I'm thinking of? I can't remember. Infer, yeah. If you can infer from the name, many-to-many relationship. What do you guys think that looks like? Like, what do you guys think we mean by that? Between the category class and the task class.
So I think a category can be linked to many tasks, and then a task can be assigned to any category.
Come up again. Almost there. Come
I
up.
think a category can be assigned to very many tasks, and then a task can be assigned to any category.
You've said a category.
Yeah, so a
So there's
category.
okay. So there's just maybe at the beginning, instead of saying a category, you need to say many categories. So we're looking at many from both ends. So many
Uh,
categories can be assigned to many tasks, multiple tasks. Like you can have, um, first of all, we can have more than one category. So we can have like home, homework, schoolwork, all of those things. So many categories can be assigned to tasks, and we can have many tasks have um, wait,
be within the same category, like one category.
many tasks can use the same category. Yeah,
Yeah.
that's yes. My brain is still waking up, but yeah. So we can have multiples from both ends. So we can have many categories being accessible to many tasks and many tasks using the same category. Actually, many categories within one task, and then many tasks using the same category. I
Yeah.
think I think that's it. Yeah. Yeah. One to many relationship. Where do you guys think that would fall under
Um,
one to many?
one, one task.
That's it.
Yeah.
Yeah. So one to many. One task can have many subtasks, but many subtasks can have one task.
Yeah.
Yeah.
Yeah. One subtask can only have one task as the parent.
Yes. Yeah. Yes. A subtask. Exactly. Exactly. So one task can have many subtasks, but one subtask can only have one task as a parent. Yeah. Okay. Still waking up, but yes. So, we also have a priority label. I know that's like a feature, but if you look at it, it will still fall under task, the task class, and it will be an attribute of the task class. And then the user profile, excuse me, in the SRS will be its own class. It will have a user profile class. And then for soft delete, this is like a trash feature. That would still fall under a task, and it will be an attribute. We can have it as like is trashed, and we can access it as a task dot with the dot, like a dot notation. Yeah. Anyway, it will still fall under task, the task class. So let's look at this example. I think we've talked about all those things. We've talked about everything that's captured in this. I think there's one thing that I haven't talked about, which was the derived or computed. Let's see if I can okay, I'll come back to that. But everything else should be covered. With regards to visibility, like we have the plus signs showing that it's public. We have the type. You guys remember was one of the things in the so this type here is what we have here. This int, string, text. I know we haven't used constraints, but if we were to use constraints, we'd just have it next to it. So usually it's put like at the end here, and it could be required, null, something like that, just to show express more like what are the constraints or what are the limitations of that property. Anyway, so we have the visibility, the plus, we have the name, we have the type, and then all of this are the properties, and all of this at the bottom are the methods, and then this is the name of the class. I think this is straightforward, not unless there's a question on it. Okay. So association. What are associations? They're just links between classes, and it kind of tells us what those links are, like what is the behavior of the links. We use it to make relationships explicit so that our schema, our designs, they stay consistent. So it shows a connection, like which classes are linked, because not all classes will be connected to one another. And then it shows multiplicity. You see what we were talking about with one to many, many to many, many to one. So we will have that shown somehow in the UML class diagram. And then it also shows direction. Like direction shows something like inheritance. So if we are inheriting from, let's say, I know in our example we don't have inheritance yet, but we could have a system that has that, and it's important to show it through. You'll find an arrow going down, meaning, is it going down or up? I think it's up if it's inheritance. I can't remember, but I'll confirm that. But direction is very important because it shows us the flow of the relationship. So bidirectional just means it goes both ways, and unidirectional means it just goes one way. And then roles. Roles are helpful, they're not necessary, but they sort of help us understand the relationship a bit more. And they're usually put at the ends of the classes. So you would have it, say, under task, you would have the role like a parent, and then under subtask, you'll have a role, let's say, like child. And then in between, you can have now things like has, so, or owns or tagged, anyway. So you'd have parent has child, something like that. So that when you're looking at the diagram as a whole, you can almost read it in, like, it's so easy to read and understand how these classes are related to one another. So with regards to our project, task is linked to subtasks. So we would say a task has subtasks. So in between task and subtask, we can put a name, we can put a description within that relationship, that connection, and you can have it as has. And then we can say that a task is linked to a category, and put and name that relationship. We can label it as tagged by. So our tasks are tagged by categories. And then for user profile and tasks, that relationship, we can say a profile. In this sense, no, I'll leave that as an example for you guys to tell me. But a profile owns tasks. So let's see if we can have. I hope you guys can see this a little clear. I know it's a bit zoomed out, but these are the labels I was talking about. So we talked about task is linked to subtask, meaning it has subtasks. So you see this. So this is concrete relationship. It's filled with, it's a black diamond, and it has the has label. So if we were reading this, we were looking at task and subtask, we would say that a subtask has, no, a task has subtasks. And then if we were to look at the multiplicities, you see these numbers at the end. They're usually at the far end, but in this case, because the diagram is so small, it looks like it's like in the middle. But if you look like at this example, let's define the multiplicities first. Excuse me. So if we have 1, it just means 1. If it's 0 to 1, it's just 0 to 1, and then the asterisk means many. So this means 0 to many, and then this other one means many to many. No, 1 to many. So in our case, we'd have tasks and subtasks. One task will be linked to 0 to many subtasks. For task and category, you can actually have many to many, but 0 actually to many, and 0 to many categories. So when we are starting off, the system can exist without any tasks. And even if you have a task, you don't necessarily have to have a category. Like, so the task can have 0 to many categories. That's why we are starting from 0. And then we are going to use a joint table because we can't directly link them, and you will see that in the diagram. So we'll go through the diagram one more time. And lastly, between the user profile and the task, we have a 1 to 0 to many. So a user profile can exist. So that's 1. That's why it's 1 and not 0 to 1 or 0 to many. So the user profile must exist. So it's 1. And it can exist without a task. So that's why it's 0 to many tasks. So now let's look at the system as a whole. You guys remember the status, right? It's just on the side. It's more like we identify it, but it doesn't necessarily have fixed relationship per se. It's more like if you use it, it's like a type. Yes, it's a type. If you use it, these are the options that. So in this case, if you look at the task class, we use it under as a property, a type of. So this property of status is of type status, meaning it can pick between. You can pick between these three options that we talked about. So now let's start from the top. We mentioned 1 to 0 to many. I don't know if you guys can see this or if I need to zoom in. Can you guys see this okay?
It's not clear from my end.
Okay, so let me do this. Um, I don't know if I do this, if it will be zoomed in. It's not. Okay, so is this any better really?
Yeah, that was better.
Let me zoom in with regards to this one. I think this one is a bit, yeah, this way. This is better, right? Like you can,
Yeah.
okay. So let's see, first of all, what the class has, and then we look at the relationships. So we have the user profile class. It has these properties. So visibility wise, all these properties and methods are
Public.
yes. So they're all public. And then so they're all public, and then these are the different types. So we have int, string, and then we have a method that takes in these properties. Anyway, so this is what we have: properties, methods. For task, we had looked at it before, so we don't necessarily need to look at it now. And then we have the subtask class. These are the properties, and then these are the methods, and then category. And then this is what I was talking about when I was saying there's a joint class that we can't directly connect to any. We'll get there. So we said the user profile to task, the relationship is 1 to 0 to many. So we can only have one profile and 0 to many tasks. So one profile can have 0 to many tasks. And then in this case, we can say the user profile owns the task. So this label here kind of helps us describe that relationship. So user profile owns task. In this relationship between task and subtasks, we'll say one task has 1 to 0 to many subtasks. And then we'll say the task has subtasks. One task has many 0 to many subtasks. So in this case, between task and category, you can see you can have 0 to many tasks and 0 to many categories. But we have to have a joint class called task category because you can't get it directly. And in this case, the relationship is 1 to 0 to many relationship. So you'd say a task, first of all, with this one, different tasks, 0 to many tasks, are tagged by 0 to many categories. So many tasks, this is the many to many relationship. Many tasks can be tagged by many categories. And in this one, it's more like one task can have 0 to many categories. In this other one, between category and task category, one category, you can have one category in 0 to many task categories. I know it's a bit confusing, but one category in many task categories. And one task can have 0 to many task categories. I think this is just a breakdown of this. Actually, it is a breakdown of this. I know this wasn't super clear, but I can try and explain that with more documentation. I'll see how I can send that to all of you. But is there any question? As at least, do we have an idea on what we mean by having a UML class diagram and understanding what it means? So, like, if I gave you guys this diagram and told you to build the system, you would be in a better place to build it correctly. Like you'll all have an understanding of what is expected when building the system.
Yeah.
Does it make sense?
Yes.
Any questions? I know this last part, apart from this last part, um, any questions you guys might have? Is there any?
No question. I'm good.
Okay. So I think that's it. We might be ending a little early today. So yeah, I'll think of an assignment for you all. The apart from you guys reviewing the code and reviewing my comments and working on resolving my comments and what else? Apart from that, I'll send you guys another assignment just to do a simple write-up. See if you can better understand what UML classes can do. And I know we missed an assignment on use cases, use case tables under SRS. So I'll see if I can also add that as an assignment. I'll make sure it's simple. In general, does anyone have a question, even if it's not about today's topic?
Um, is there a video for last week's session? Because I
Yes.
understand you did as well.
Yes. And I am sorry for the
Okay.
delay. It's been a very crazy week. So what I'll do
Ah,
is, as well as today's video, I'll process it, and then I'll edit it and upload it. And once I've uploaded it, I'll share it in the Google Classroom as well as Discord. And then, yeah. But we have a
okay.
recording. Yeah.
Okay. Yeah. Thanks. I appreciate.
Okay.
But I see there are the notes for the section for
Yes.
Agile.
Yes. For Agile, I think I published the notes already. So,
Yeah.
yeah.
Okay.
Okay. So for this one, I'll also publish these notes for today. So you all can have access to that as well. Yeah. Um, so I guess that's it. If we don't have any questions, today's meeting wasn't as long, so you'll have about we're done in half of the time, half of our usual time.
Mm.
Are you guys facing any challenges with regards to coding? What you're working on?
No problem.
Okay.
Promise.
Okay. So I think that's it then. Let me think of an assignment that makes sense for you all for UML and also for use cases because we didn't do that. And then next week we will work on OOP. Yeah. Okay. So if there are no questions, I guess we can end the call there today. It's been a short one though.
Yeah. Mhm.
Yeah.
Okay, good.
Okay, guys, have a good one. Okay,
Yeah, enjoy your weekend too.
Bye bye.
will do. Bye bye.
Bye. Bye.
Bye.
Thank you.
Bye.